Hello guys, in today's video we will cover dimensional tolerances on engineering drawings and explain the basics concepts. Even though man is a perfect creator, in engineering manufacturing he has not yet been able to manufacture and measure any objects absolutely accurately. Actual surface and objects, parts and the like differ in size, shape and position from ideal surface, as you can see in this picture. This difference is due, for example, to the inaccuracy of production machines and jigs, to deformation and chatter of the workpiece, tool and machine tool, to unevenness and internal tension in the material. The mutual assembly of manufactured mechanical components is intended to ensure a certain function of the component as a whole even in the presence of manufacturing inaccuracies. It is then sufficient to achieve satisfactory functionality if each dimension of the component is manufactured between two tolerances represented by the tolerance. Tolerance is therefore a system of accuracy and deviation from nominal dimension and is given by the allowable inaccuracy. To ensure the functionality of the fit, the actual dimension of the product needs to be within the tolerance. In engineering, tolerance systems are used, and that is a set of rules for determining manufacturing errors appropriately so that the requirements for part function is met and the manufacturing cost of producing the part is as low as possible. Tolerances can be applied directly to the dimensioned features using limit dimensioning. This is the ASME preferred method. The maximum and minimum sizes are specified as part of the dimension. Either the upper limit is placed above the lower limit, or when the dimension is written in a single line, the lower limit precedes the upper limit and they are separated by a dash or by a slash. As you can see in this picture, with this approach the basic size is given, followed by a plus, minus sign and the tolerance value. Tolerance can be unilateral or bilateral. A unilateral tolerance varies in only one direction, while a bilateral tolerance varies in both directions from the basic size. If the variation is equal in both directions, then the variation is preceded by a plus and minus symbol. The plus and minus approach can only be used when the two variations are equal. This figure shows a system of two parts, machined part with a slot and matting part that have tolerance dimension. These two parts are used as an example in ASME and ANSI standards to define important terms. Nominal size is a general size common fraction. Basic size is the theoretical size used as a reference for the application of tolerances. This size is shown on the drawing in a rectangular box. Actual size is actual measured size of the finished part after machining. Limits of size is the maximum and minimum permissible size between which the actual size should lie. The larger value for each part is the upper limit, and the smaller value is the lower limit. Allowance is the minimum clearance or maximum interface between parts or the tightest fit between two matting parts. Here is the example. The slot and the matting parts have basic dimensions of 0.500 inches. Lower and upper limits of the slot are 0.498 and 0.502 inches. Correspondingly, lower and upper limit of the matting parts are 0.495 and 0.497 inches. In figure, the allowance is 0.001, meaning that the tightest fit occurs when the slot is machined to its smallest allowable size of 0.498 and the matting part is machined to its largest allowable size of 0.497. The difference between 0.498 and 0.497 or 0.001 is the allowance. Tolerance is the total allowable variance in a dimension, the difference between the upper and lower limits. The tolerance of the slot in the example is 0.004, because 0.502 minus 0.498 is 0.004 and the tolerance of the matting part is 0.002, because 0.497 minus 0.495 is 0.002. So this is all for this video. In next video we will talking more about tolerances and we dive into tolerances related to the fit to the hole and the shaft. Thank you for watching and see you in the next time. Bye.